First of all, we want to create 2 measuring steps. We click on Insert on our keyboard, and then 2 measuring steps appear. Now we go to measuring step number 1 and want to determine the highest tooth here. Cutter shape 21. Measuring mode measuring. And our measuring range is from 1.3 up to 1.3. Cutting on the circumference is 10, but it depends on how many cutting edges your tool has. The Z dimension must be determined depending on the overall length, but in our case it is 63. Our X dimension is 200, this is our diameter. And now we go to measuring step 2. We enter 21 for our cutting edge shape. Measuring mode is setting. Measuring range is again 1.3 up to 1.3. Now cutting on the circumference is again 10. Z dimension is now special. We need to enter 0 and go to target actual dimension mode. We click on incremental to measuring step 1. This means the highest tooth of measuring level 1 is taken now and set as 0. Our upper tolerance limit is 3 micrometer and lower tolerance is -3 micrometer. X dimension is 200. First of all, we must clean all of our cutting edges with the cleaning clay. Because we adjust our tool to the exact micrometer, it is really important that everything is clean. Now we take our measuring step 1, which we created previously, to determine the highest cutting edge. We start a program and the tool travels around once and measures every single cutting edge and creates an overview from cutting edge 1 to cutting edge 10. This is our overview. You can see the 9th cutting edge is the highest one with 63.166, and we have a Z difference of 0.161. We have now made our first step, and this is the basis for measuring step 2. Our individual cartridges are now being aligned. Indeed, by the tolerance we entered earlier, 3 micrometer up to -3 micrometer. We're starting the program now, and the tool travels around again and go through cartridge by cartridge. As you can see here now, it's in the red area, which means it's outside of our tolerance, so we must adjust the cartridge. To adjust it, we take our Torx 15 and go to our differential screw. If we move it counterclockwise, we move our adjustment piece, and when unscrewing, the whole thing rotates in that direction upwards. Height adjustment through a preset wedge. Very important, the adjustment of our cartridges always happens in a clamped stage. The clamping is not released. Now we turn our differential screw counterclockwise, and thus our Z dimension moves from the red zone into the green range to 0.0. Through the color you can see that everything is in order now, and we can continue with the next cartridge. We now arrived at our 9th cutting edge, therefore you see here Z is 0, because earlier our 9th cutting edge was our highest one, and we do not need to adjust anything and we can just go further. Now the last cutting edge is being measured, and then at the end you will get your protocol. Here we have our overview from the protocol, and you can see all the cutting edges were set exactly to 0 micrometers. Down here, once again, a difference of 0 micrometer, and it is really possible to set a tool so precisely. Very important side note, our X dimension here, we see a difference of 86 micrometers, but it can also be over a tenth. This is absolutely irrelevant. Because we do pure finishing with our tool, only the Z dimension is required. So in case the question should ever come up why there is such a big difference in the X dimension, with such a large cutting edge like we have on our tool, a tenth doesn't matter at all. At some point, the mechanical end of our cartridge is reached, and it can no longer be screwed higher. So a reset to the basic position is necessary. To give more power and more torque, we build ourselves a T-handle. Now we take our Torx 20 and we go in our locking screw and loosen this with 2 to 3 turns. Important, do not unscrew it completely. With the Torx 15, we loosen our lower screw. And then we notice that the adjustment wedge can now be moved and the cartridge is also loose. The adjustment piece must now be reset to the basic position by turning the differential screw clockwise until it stops. And then we give a small impulse in the opposite direction to loosen the adjustment piece. Now we have to do everything in reversed order. So we first have to go back to the clamping wedge and clamp it. It is best to hold the screwdriver with only 2 fingers to lightly position the adjustment wedge. With the soft-faced hammer, we give 2 to 3 taps to the cartridge. Then I can screw everything tight. Afterwards, I enter again 1 to 2 taps on the cartridge and thus the cartridge is set. Now we tighten our locking screw again with our Torx 20. Now we have set back our cartridge to the basic position. And it is important when we now adjust the wedge that only after a quarter turn something will move within the cartridge. When the mechanical end of a cartridge is reached, it is normal that also the other cartridges will follow soon. So usually you can see it at the adjustment wedge. It is now far inside, which means that it's not flat here. So you can see it, for example, at the other cartridge next to it, that the adjustment piece is a little bit far out. So you can see it is sticking out here. That simply means that the cartridge has already been adjusted many times, and at some point it just won't go any further, and then the resetting of the whole cartridge in starting position is necessary. Over time the parts wear out, especially this differential screw down here. All the components of the cartridge are available from us. That happens, for example, through adjusting in general, or if the clamp is tightened too firmly, then the screw head gets broken. We are now doing the same as we did with the resetting to the starting position. We loosen our fastening screw by 2 to 3 turns. Then we loosen the screw underneath. And thus we can take out the whole cartridge. Now we are loosening our screw in order to change it. We unscrew it completely up to the point where the adjustment wedge can now be pushed upwards. Then we can see that our screw at the bottom has about 1.5 visible threads. So if we take out the screw now, and screw the new one in just as far as the old one was. Now we take back our adjustment wedge onto our screwdriver, and then we drive in here and slide the adjustment wedge over the screwdriver. Fasten everything together and press it down a little bit. Then we can screw everything tight. The adjustment wedge is then pulled in with it. At the very end, we give again a little impulse against the direction of the rotation. We can now reinstall the cartridge, and we see here the gearing of the cartridge. It is the same gearing as we have in our cutter body. It is very important that we insert the cartridge correctly. Now we proceed again as when putting it into the starting position. We hold the cartridge firmly and then slightly tighten the bottom screw. Then take our soft face hammer, give it 2 to 3 taps, and then completely tighten the bottom screw. Again, 2 to 3 taps with the soft face hammer. And now we can completely tighten the locking screw at the top. When changing the indexable insert, it is very important that we do not insert the new one incorrectly. We are now screwing the indexable insert out first. Then we look that our insert seat is completely clean. We clean it again with our cleaning clay. And we also looked at our contact surfaces of our indexable insert is clean as well. We are now deliberately putting our insert in incorrectly. We could still screw the insert tight now, but it would notice during the screwing that it is very, very difficult and the screw can hardly be turned in. So we really must ensure that our contact surface here and also on the lower contact surface that the insert is completely against it. Means we now take 2 fingers, press the insert in gently, and then go down along the side. Then we can push it in, and we can be sure that the insert is really sitting in correctly. Now you can screw them tight. It is also completely normal that the last quarter until half a turn gets heavier. It is the tightening. We can be sure that the insert is really pulled into the corner.